Hopefully you're able to remember how to solve these types of problems. The answer was 5 meters per second squared. You just use your equation and plug in the numbers. Pretty simple. Now you might be asking yourself, why are we going back to this? Didn't we already do this? Why would we ever go back to something we already know? Well, I'm glad you asked, mythical student, because we have more equations to come. This one right here is where a lot of people start struggling in physics if you haven't already. Unfortunately, physics doesn't necessarily get easier until you start figuring out how to approach problem solving. Once you do that, everything just kind of clicks. So what do I mean by that? Well, we gave you the guess method for a reason. This is your approach to problem solving. These first 3 letters right here are going to be the key to just about every single problem in this class. Once you figure out your givens and your unknowns, you will be able to choose the correct equation, because in this class, every equation has specific variables and there's no overlap. So if you had 4 variables and you had A, VF, VI, and D, this is the only one that can possibly work for you. If you're given more variables, then you can kind of pick and choose. But if you're only given 4 and it happens to be these 4, this is your equation. We don't have anything else there to trick you. Okay? So, let's go through an actual problem. A roller coaster's velocity at the top of a hill is 10 meters per second. This is my VI actually, because we're starting at the top. It reaches the bottom of the hill 18 meters later. Ooh, tricky. This one's our delta D with a velocity of 26 meters per second. This is our VF. Okay? So our acceleration is our unknown. And I'll go ahead and start changing colors for you. So, VF is equal to 26. VI is equal to 10. Delta D is equal to 18. Normally, I recommend to do this while you're writing the numbers out. But again, I am recording and sometimes my brain forgets things. All right. Our unknown, like most of the time, is acceleration. Okay. Pretty straightforward. I gave you the equation. The only equation that has A, VF, VI, and delta D is this one right here. Okay. And then we just plug the numbers in. So A is equal to VF squared, which is, I don't know why I rewrote that, 26 squared minus 10 squared divided by 2 divided by 18. The trickiest thing for this problem, you need to use that online calculator I gave you. I will link it in both the pair deck and the upcoming assignment. You need to use those parentheses. So do parentheses around this part. Okay? And then also do parentheses around this, 2 times 18. Why, you're probably asking? Well, this can go wrong many ways. You could do 26 squared minus 10 squared divided by 2 times 18. This is actually something that would happen to a lot of you. Or you can have 26 squared. You get the first part right. You do everything right. You even divide by 2, but then you multiply by 18 because you accidentally forgot parentheses around the 2 and 18. So be careful. This actual answer is 26 squared. Let's even do it together. Minus 10 squared. I'll show you what might happen if you do it wrong. Divide by 2 times 18. That can't be right. So let's start putting parentheses around it. Okay. We're getting a little closer. And oh my goodness, if I put parentheses around everything, like I was saying, you get a whole number of 16. There will be some decimals probably going forward, but those other numbers are way too big for there to be an acceleration that large. Just think about it. We don't even travel 250 meters per second. So there's no way it could have been that large. So make sure you check your numbers, that they make sense, and you use these parentheses. These freaking parentheses are going to be the death of me and you. So don't do it.